Oh, hey, welcome back. I'm glad you could join me. This is the third video in our series where I'm building up the Nexus DRX digital radio cross patch. And before we start adding the connectors over here to our board, I'd like to answer a question in the comments from Larry. He asks, just what is a cross patch? Well, the term comes from an old term that we used to use in amateur radio called a phone patch. A phone patch allows us to take a telephone conversation and put the person who's on the phone onto the radio, and you can use amateur radio to talk great distances. My father, when I was a kid, used to run phone patches with servicemen in Korea so that they could talk to their wives when they were here home in the States. So let me show you over here on the board what we're doing. So this is our FEPI. This is the sound card that we'll be using. We have our own version of it right here. That they're both the same. And the FEPI has two audio jacks on it. This one is line in and this one is line out. And we're going to patch these two together. So the line in will go down to this jack right here, which will pick up our receiver's audio. And the line out will be patched down to this jack over here, which is our radio's transmitter. The audio will go out the transmitter. Here's one that's all built up, and you can see it here. The patch cables are in there. Now, what's going on here is that each of these audio jacks, the input and the output, are stereo, which means they have a left side and a right side. Both of them do. And so what we're going to do is cross those audio paths to radio connectors that are going to be right here. We haven't installed on our board yet. We'll do that here shortly. So what happens is our left line in will go down to this jack here, and we will send it over to our left radio connector. Our left audio out will go through here, and we will send it over to the same radio connector. So both left input and left output will cross over to the same left radio connector. And both right input and output will go to the right radio connector. We'll also add push to talk to these two circuits so we can turn our transmitter on and off. So that's why it's called a cross patch. You can find more information about the Nexus DRX digital radio cross-patch on my website. There'll be a link to it in the description below. Okay, let's juice up this sponge and get ready to build. If you'd like your own Nexus DRX kit, go to wb7fhc.com to find all the details. Okay, according to the directions here, the next thing we're going to do is put some header pins on the board. I'll show you here. We have a set of header pins. They're going to go in various places along the board. We have some for 1200 and 9600 baud, 5 volts and ground, 3.3 volts and ground. We have connections for UART and connections for a real-time clock. And we'll put those on the board next. You're going to find that your kit comes with a stick full of all these pins, and what you do is just snap off the number you need. So I'm going to set some 3-pin header right in here where we select the 1200 and the 9600 baud rate for the left radio. So I'll just break off 3 of these pins right here, and we'll put them in here. Now, you may notice that right over here, I already have 4 pins soldered on. That's because I just filmed doing that and found out that my microphone was muted. So this is basically a retake. So we will put this guy down here, and I'll use a little bit of tape that I have handy here. to hold that down, get it in place, and then I'm going to solder just one of those 3 pins right here. Maybe this guy right here. Now we'll take the tape off and we check it, and this is difficult to get these straight. So now I deliberately soldered the pin that's closest to the edge of the board so that I could put my finger here on the 2 that I'm not working on. These things get really hot. So I'm going to just melt that connection right here and seat that, kind of like what we were doing with the LEDs. And there it is. It's nice and straight. Take a little effort, get it straight. You'll be happy that you did. Now I can go ahead and solder the remaining 2 pins. Come on. There we go. Just like that. Okay, so you don't need to watch me solder all these pins. There's quite a few of them. When I get done, I'll show you what they all do and talk to you about some of them that are optional, some that you might choose to not even bother to put on your board. I'll be back soon. Okay, I'm back. I've done all those pins. Let's go down the list and I'll check them off. First of all, it says we're going to put 2 3-pin male headers on at the 12 and the 96 point. That's these pair right here. And of all the pins that we put on the board, these are the most important. The audio from our radio coming in through these jacks right here will come in through one of 2 sources, depending on whether you're set up for a 1200 baud or a 9600 baud connection. We'll talk about that in more detail later. So these pins right here, this switch between the 9600 and the 1200 and bring it to the center pin with a jumper that we'll put on here in a little bit. If we don't have these pins in here and we don't have this jumper here, you're not going to get any audio into your Raspberry Pi. So those are essential. They have to be done. And I'll mark that off that we've got that. Looks like I hadn't marked off our transistors there before. Okay, so we'll put a check mark there on those. Over here, we've got pins for 5 volts and ground. I usually put pins like this on the board as a option for at some point in time if I have another project that needs 5 volts, I can grab it here. These are optional. You don't have to put them on. It's just a handy thing to have. Sometimes I put a 90-degree angle pin in there so that I can plug in sideways. But I have a lot of projects around my bench here that need 5 volts, and I tend to grab them from something like this because it's got 5 volts on it anyway. I did the same thing over here with the 3.3 volts and ground. So they're just there in case we need them. Maybe you use them in some other project. Maybe you have a breadboard, some creative thing that you're doing. They're handy to have and you can use them. So I can mark those off here that we got the 5 volts and we've got the 3.3. Over here at this end, we have connections for a UART. This allows you to hook a PC, for example, directly up to your Raspberry Pi. You won't need a keyboard, you won't need a mouse or a monitor, and you can use a serial connection to run the Raspberry Pi. It's there if you ever want to use it. It's also optional. You could leave those pins off if you think it's something you would never use. And then mark that. Finally, down here, there are 5 pins, and these are going to hold our real-time clock breakout board and run it. Those are also somewhat optional. The real-time clock is handy if your Raspberry Pi doesn't have any kind of an internet connection. If it has no internet connection, it doesn't know the date or the time. But if you have an internet connection, and you're always going to have it hooked up to either Ethernet or a Wi-Fi, you don't need these. You don't even need the real-time clock module that you'll be putting on there. So that's somewhat optional. Anyway, I've got all of those pins in the board now. Let's take a look and see what's next. According to the directions, we're going to add some more header pins. This time they're going to go with the TRRS breakout board. In fact, those pins come with the breakout board. They're same as what we've been using. There's our power supply, a real-time clock. Now here's what we're looking for. You're going to find a little bag in your kit with a tiny red board in it. Let's open this up and see what we find. Take this out of the way. And this is a breakout board. It's interesting that we came by to use this device. Maybe I can zoom in for you and get the camera to focus on it. This is a TRRS jack, and it's a surface mount part that is already soldered onto this little tiny breakout board. We're going to use these 4 header pins, they're just like the ones we were just using, to mount this to our board. There's a funny thing about this. The reason we are using this breakout board instead of soldering one on our PCB ourselves is that it's cheaper to buy them on the breakout board than is to buy them loose. At least so far, that's what I've found. And they aren't expensive, and it's a convenient, easy way. You don't have to mess around with any surface mount parts. Now, the breakout board itself isn't going on right now. What we're going to do is we're going to put the headers on the bottom of the board here, like this. Go like so. The opposite side of the board from what we've been using before. All the other headers went on the top of the board. This header goes on the bottom of the board. And we do this pretty much the same way that we did the others. I'll come down here and I'll solder one of those pins. And then we'll flip it over and I'll check it to see if it's straight. You know, I did a good job that time, I think. Oh, it's leaning a little bit. If we let it lean, that will be a problem because we're going to have a part attached to it. That got ouchy. That's what I say. You got to watch out where you put your finger when you're reworking those headers. So, okay, it's on the bottom of the board. I'll go ahead now. Oh, let's look. You know what? It's still crooked. Okay, one more time. Get my finger away from the hot spot. Okay. That should be better. I'm looking at the pins coming through the hole to see if they look straight. And, oh yeah, okay. I'll go with that. Let's solder that thing on. Yeah. Okay, so this is going to go on here like this. But we can't put it on yet because we're going to have to solder something on this part of the board. So once we get our piano switch in place, then we can put the breakout board on there. So I'll just set this off to the side and let it sit. We will get our directions up and mark that off. Yes, and the next thing that we're going to put on is the piano switch. Okay, we were looking at that earlier in one of the other videos. It's this guy right here. When you do your kit, some of them are red. They're all identical, so don't worry about the color. But if you have a red one, it's the same thing. It goes here on the board. Just Might have to adjust the pins a little bit if they're bent slightly. You want to be sure that the piano switches themselves are pointing out towards the edge of the board so that you'll be able to actually use them, okay? If you turn it around and put it in the other direction, you'll be able to solder it in. It'll still function just fine, but you won't have easy access to these when we put a top on the board. So I'm going to just flip this over as is, and it sits fine on there. Because we are putting our parts in according to the height, we can flip this board over, and that piano switch is sitting right down here on my green pad. So I feel it tight there. I'm going to go ahead and put in 2 corners, and we'll double check everything. It looks good. We'll just go ahead and hit them all. My soldering iron times out, and I have to flip the switch every now and then to get it to come back up to temperature. So it timed out on me right there. We'll give it a few seconds. It'll be up, and there, we're back up to temperature. I run my iron at about 720 degrees Fahrenheit. I'm not sure what that is in Celsius, but that's a little on the hot side, but it means I can work quick and usually get pretty good solder joints with that. Okay, there's our piano switch on the bottom side. There it is, ready to go. Right there, like that. Pretty slick. Okay, let's mark him off. 1 piano switch. Okay, now it's time to find our little shunts. I took them out of the bag some time ago, and now they're on the bench here. Let me hunt them up, and then we'll get right on with those. Okay, your kit comes with 2 of these jumpers. They got an opening on one end and not on the other, and they simply slide over 2 of the pins there. The first time you put them in, it may take a little effort to punch it down as they open up and get in there. I'm setting my pins, jumper, on the 96 side of the set of pins there. This works just like a switch, if you will. You see, it'd be like we could put them on these 2 pins for 1200 and on those 2 pins for 9600. Now, this whole thing about 1200 baud and 9600 baud is kind of misnamed as far as radios are going. What we're doing here really doesn't have anything to do with the baud rate of the radio. It has to do with where we're grabbing the audio. Your FM radio has a discriminator in it, and to get good, clean 9600 baud packet, we need to be sure that we're on the inside of the discriminator circuit before it goes through and gets all twisted around and messed up and comes out the speaker. So that's what the 9600 does. If your radio doesn't support that, you may have to put your pins, the jumpers that is, over on the 1200 side. The 1200 side is going to be audio just pretty much the same thing you would hear out of your speaker. When you're hooked up to the 1200 side, your volume control is going to affect what happens when the data comes into the Raspberry Pi. Your squelch is going to be affecting what comes in. If you're on the 9600 baud, your squelch and your volume control are completely independent of what we are going to send to the Raspberry Pi. So if your radio will support it, always choose the 96 side. Don't worry about it. Even if you plan on only running 1200 baud, I run an APRS fill-in digipeater here, and I run it at 1200 baud, but my jumpers are set for 9600. And you just get cleaner audio. So if 96 is a choice, choose it. When it comes to setting up your station and you're looking at FLDG and you're looking at your waterfall, if you find that there's absolutely nothing in your waterfall, it's just black, the first thing you want to do is move these jumpers to the other side. It may be that you've got them on the wrong pins, and that all has to do with maybe what cabling is going on. Basically the wires inside your cable is what I'm trying to say. Let's see what's next. Oh, we get to check that off. Okay, so now we're going to put on some jacks. Power jack, an RJ45 jack, and a couple of the MiniDINs. We're really moving along here. This is the power jack right here. It's just a little barrel connector. It's got 3 prongs on it. We'll talk about why it's got 3 here in just a second, but I want to show you what's going on the printed circuit board. The power jack is going to go right in here where these 3 holes are. Take a look at it on the PCB. You see over here, this is the power jack going in here. I was never able to find a footprint in Fritzing, which is the program I use to lay out this board, that matched this power jack. So I had to just design this one myself, and I used these round holes that go through the board for it. And the power jack is kind of, they're blades, and it would have been nice to find something a little more rectangular, but it didn't seem to be available. So that's why we end up with those holes in there. This is a barrel connector, and you see it just plugs in like this. Well, the question might be, well, why are there 3 pins here? And the answer is that one set actually acts like a switch. So when we plug our plug in, we are opening a switch. When we unplug the plug, these 2 pins right here are tied together. This one is ground. This is the end of the switch. So we have grounded our switch, which means we could write software that tells whether or not something is plugged in to our barrel jack. We plug this in, it opens the switch, and this piece right here now is no longer attached to ground. On our circuit board, we don't need a switch, and I have actually tied them together to ground. Our voltage, we can run anything from, say, 9 volts up to 32 volts into our board, will come in on this pin right there. So let's see. This is going to go in here like this. And because the pins are blades and the holes are round, it's going to swim around in here a little bit. So you could take a little effort and tape it down and try to get it a little bit straight there. Those holes also had to be fairly large in order to get the whole width of the blade through them. So that's why it kind of swims around in there a little bit. Now I'm gonna, because I have it, I have some solder here that's a little heftier than what I've been using, and I'm going to use this solder because it'll fill up these holes quite quickly. Now I'll go ahead and when you're soldering a big connector like this, you have to heat that connector up. It's not like the little pins that we're used to doing. It'll go, and we get a nice big puddle of solder there and kind of fill that up pretty good. I'll pull off the tape. I'm going to look at my connector. It's not terribly straight. You know, I could put this in there and use it to help straighten it out. I'm going to just kind of melt this up a little bit. Again, it takes longer because it's a big connector. And there. That looks pretty straight. We'll go with that. Pull that out. Now, one of the advantages of having these larger pads is that this provides us with some good structural strength. This is a plug that you'll be pushing in on and yanking out of. So it's nice that it's got a little bit more holding it to the board than some of the other connectors. They have other mechanisms to hold themselves tight to the board, but there we have it. That's pretty good there. I'll bring up the directions. We will check off the power jack, and now we're going to put on an RJ45. All right, that's this guy right here. This is a connector that is basically like an Ethernet connector. It's not going to be an Ethernet connector. What we're doing here is we're actually imitating a signal link. It'll become obvious here in a few minutes, but many of you have signal link cables for your radios. If you do, you'll be able to plug it right in here to this jack, and it'll work same as it does on a signal link. So this guy goes on the top of the board. There's 8 pins in there. They all line up, and then once you get it in place, it snaps in. And we were talking about having structure for connectors. These black pins right here snap into the printed circuit board, and they will provide the strength that we need. So when you're inserting and yanking out a plug, they will hold it in place. We're not going to put the tension down on those boards there. I think I'd like to grab Agnes's jig for this one. I've got a bunch to solder, and assuming it'll fit with the RJ45 on there, looks like it does. We will put this in here, and there. Get it all set up. Looks good. I can maybe zoom in for you. Solder these guys up. My tip needs a little cleaning. RJ45 soldered in place. These are standard 6-pin MiniDIN connectors. These will go right from our Nexus board to our radio. It's great when you can find a radio that has this standard data connected on the back. Cables are easy to find, and you just plug them right in and away they go. We're going to put 2 of them on the board, and it might take a little widging around. I strongly recommend that you don't do the far one first. Otherwise, it's hard to get this middle one in. So we'll do this inside one first. Just line that up and push it in like that. We'll solder that down. Get our little jig. It snaps in place. I'm going to go ahead and solder a pin here in the corner. Take one quick look. There's no way to remove this thing without actually destroying it. So don't be afraid to be too cautious. You'll never regret it. Okay, we'll solder all of these connections. And then these are for structure here. There's no electrical connection on those. Okay, that looks good. I'll go ahead, put the other one on, and we see what's next. Okay, we've got those guys on. They look good. Pull up the directions and check off Another item on the list. Okay, it's time to go back to that TRS breakout board and put it on. That should wind us up for today. Let's see, I've got it right here. We've got these pins here. Let's just put these on. I'm going to solder just one pin on the board here because it's slanting down. And we'll just put solder on one, and then I'm going to hold it in place. Remove the soldering iron. Let it get solid. Kind of eyeball it. There's going to be a connector of the Raspberry Pi right underneath this thing. So we want this to kind of come out level. It's looking a little better. Yeah, that looks good. We'll solder the rest of those pins down. And now, those are good to go. These pins, we don't normally do this. These pins are pins that, if I can move him down a little bit on this side, I may have missed that opportunity. Yeah, he's good enough. These pins I'm going to clip off and they're going to fly. So be careful. Don't normally clip those off, but in this case, because we're going to have stuff underneath it, we'll kind of clean that up a little bit. Well, that just about winds it up now for right here. That's a good place to stop. And we got probably one more video, a simple one. We're going to put the header on here next time, and then we're going to start assembling the stack itself and getting all the pieces together. Oh, we will also be putting on the power deck. That'll be a lot of fun because we're going to adjust the voltage. So anyway, this has been a lot done this time. Hope you'll join me next time. I'll look forward to seeing you then. And hey, don't forget to subscribe, like, and share.